Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to talk a little bit about how to calculate tangential accelerations and tangential velocities for problems with rotation here in the language of vectors. So imagine we've got some sort of object here, doesn't matter the shape, and imagine that it is rotating in a plane where here's our rotation axis about some point here. And just to make this a relatively simple example, so let's imagine it's rotating counterclockwise and also accelerating counterclockwise. And we're going to take a look at the point P out here. So if this thing's moving counterclockwise or rotating counterclockwise, then the velocity of this point might look something like this. And that velocity has to make a right angle to this line that intersects the axis of rotation. So what I'm going to do here is I'm going to call this distance r. Whoops. And I'm actually going to define a position vector now that points from some point on the axis of rotation to the point P. Now, if this thing is rotating about an axis, P is undergoing circular motion. And in one of my previous videos, I talked about how to calculate the tangential velocity component, and it's equal to r times the angular velocity. What I talk now is how to describe that in the language of vectors. All right, so we've got this position vector here, and the magnitude of that position is going to be this guy right here, and we've got the angular velocity vector as well. I'm just going to rearrange this a little bit, and we're going to call this the angular velocity times r, and now we're going to talk about direction. Notice that the angular velocity vector in this example points this way. And notice if we take the cross product, and if you're familiar with how to do cross products, or if you're not, go back and watch my video about how to do a cross product. Imagine putting your fingers along this axis and then crossing that with the position vector. Your thumb would be pointing in the direction of this velocity vector. It's kind of hard to describe in 2D. But long story short, the velocity vector can be given by the angular your tangential velocity vector at a point P can be given as the angular velocity vector crossed with the position vector. This is just the vector way of doing this same calculation. And the vector way will be handy when the problems get more and more complex, when you're talking about 2 and even 3-dimensional motion of an object. Tangential acceleration vectors kind of work the same way. All right, so before, in my previous video, I talked about calculating the tangential acceleration by r times alpha. Well, in the language of vectors, we can get the tangential acceleration, including direction, by taking the angular acceleration vector and crossing it with the position vector r. So here's how velocities and accelerations are calculated in the language of vectors. So hope this video helps. Have a great day.